Black holes, the quietest yet most powerful entities in the universe, places where no light can escape, where even time loses its meaning once it crosses the boundary. These massive, invisible structures hiding in the cosmic void stand like gateways to an unknown realm, becoming one of humanity's greatest sources of curiosity. So what exactly is a black hole? Is it a region of space formed when a dying star collapses into itself, reaching a density that approaches infinity? Or is it a dark passage leading to an unexplored side of the universe? Think about it. So much matter is squeezed into such a tiny point that even something the size of a grain of sand could weigh more than Earth. And the moment you get close enough, light, matter, space, time, everything vanishes into a single point. This point is called the event horizon. It's a boundary. Once you cross it, there is absolutely no turning back. Physicists have been trying to understand black holes for decades. Even Einstein's theories reach their limits here. Time distorts, mass bends, and the rules of physics detach completely from what we know. It's as if the universe hides its deepest secrets within these cosmic giants. But what's inside a black hole? Is it truly a gate to another universe? Or does everything collapse into a point of infinite density? In this video, we'll explore how black holes form, how they work, what happens if you fall into one, and the greatest cosmic questions scientists still cannot answer. If you're ready, let's begin our journey toward the place even light fears to enter. In the depths of the universe, there exists a mysterious force that even light cannot escape: black holes. Even hearing their name sends a chill down your spine. But what exactly are these dark giants, and how do they form? To understand them, we must look at one of the most powerful events in the cosmos. Black holes don't just appear out of nowhere. Behind each one lies the life and death of a massive star. For millions of years, giant stars shine by producing energy through nuclear fusion. During this process, the star maintains a delicate balance between its own weight and the pressure created by fusion. But once the star runs out of fuel, this balance collapses and gravity takes over. The star begins to rapidly implode. As it collapses, atoms are crushed, matter is squeezed into an unimaginably dense point, and one of the densest objects in the universe is born. This point is called the singularity, and surrounding it forms a boundary from which even light cannot escape: the event horizon. Black holes can form in several ways. The most common is the collapse of a massive star after a supernova explosion. While the outer layers are blasted into space, the core collapses inward, creating a black hole. Smaller stars cannot form black holes. They end their lives as white dwarfs or neutron stars. Some black holes also form through the collision of two neutron stars or two black holes, an event that releases tremendous energy and creates an even larger black hole. Black holes vary greatly in size. Some are just a few times more massive than the sun, while others can reach billions of solar masses. They shape the universe not just by consuming matter, but by influencing the structure and motion of nearby stars and entire galaxies. We cannot observe them directly, but we detect their presence through the motion of stars, the bending of light, and the heating of gas around them. In a sense, black holes are both an ending and a beginning, born from the death of a star, yet continuing to shape the cosmos. Black holes are among the most mysterious and frightening objects in the universe. They stretch the limits of nature's laws and conceal their true nature behind an impenetrable curtain of darkness. One of their most fascinating features is the event horizon. The event horizon is an invisible yet profoundly meaningful boundary. It marks the point of no return, Once something crosses it, whether light, matter, or information, it can never escape. As an object approaches this boundary, its perception of time and space shifts drastically. The gravitational pull becomes overwhelming. To an outside observer, the object appears to slow down, as if frozen in place. But for the object itself, the moment it crosses the event horizon, it is rapidly drawn toward the singularity at the center. The event horizon hides everything that happens inside. Gravity there is so intense that even light cannot escape. Because of this, physicists must rely on indirect evidence and theories to understand what lies beyond. Einstein's theory of general relativity explains the event horizon through the extreme warping of space-time. But the physics inside may not follow the same rules as outside. This leads to one of the biggest mysteries in physics, the information paradox. Anything that crosses the horizon becomes unreachable, and yet black holes can slowly evaporate through Hawking radiation. Does information vanish forever, or is it somehow preserved? This debate continues to challenge our understanding of the universe. The darkest point in the universe, the singularity. This word stretches the boundaries of both science and imagination. The singularity is a region where the rules of space and time collapse, where physics as we know it simply stops working. It appears at the center of black holes and at the very beginning of the universe. The singularity is defined as a point where density and curvature approach infinity. As you get closer, matter compresses until its volume nearly becomes zero. During the Big Bang, the entire universe was once compressed into such an extreme state. The biggest problem for physicists is that our current theories break down at singularities. General relativity predicts them, but quantum mechanics introduces contradictions. That's why singularities are both a key to understanding the universe and one of its greatest unsolved mysteries. To speak of the singularity is to look directly into cosmic darkness. Beyond the event horizon, beyond the no-return line, lies a region where time, space, and matter cease to exist in the form we know. In a sense, the singularity is where the universe hides its deepest secrets. Understanding it could reveal how the universe began and where it is heading. Yet every discovery reminds us how complex and puzzling this concept truly is. The singularity is not just a physical point, it is a symbol of human curiosity and our fascination with the unknown. The darkest point of the universe might just contain the brightest light of science. If you enjoyed this video, don't forget to hit the like button and subscribe. Share your thoughts and questions in the comments. We'd love to hear what you're curious about. See you in the next video, where we'll continue exploring the universe's mysteries with new discoveries and special content for our subscribers. Let's keep uncovering the secrets of the cosmos together.